In 1 second, light travels 7.5 times around the Earth. Nothing in the universe moves faster. It's physically impossible. And yet, by the end of this video, that speed is going to feel painfully slow. Today, we're traveling at the speed of light, all the way to the edge of the universe. First, what is light? Simply put, energy that travels, carried by particles called photons. A simple example, the screen you're watching this video on right now is sending light straight to your eyes. For centuries, we believed it was instant. You light a candle, the room lights up immediately, no delay. Then in 1676, a Danish astronomer named Ole Rømer noticed something strange while observing the moons of Jupiter. Their eclipses were late when Jupiter was far from Earth and early when it was close. He concluded that light takes time to travel and therefore has a speed. It was the first time in history anyone proved it. Today, we know it down to the exact figure, 299,792.458 kilometers per second. And in 1905, Einstein added the detail that changes everything. This speed isn't just fast, it's an absolute limit of the universe. Nothing, anywhere, will ever exceed it. Not a rocket, not a signal, nothing. So if we could travel at that speed, the maximum the universe allows, how far would we get? First stop, the moon. Distance 384,000 kilometers. At the speed of light, you're there in 1 3/10 of a second. In 1969, the Apollo 11 astronauts took 3 days to make that same trip. And because radio waves also travel at the speed of light, when they talked with Earth, you had to wait about 2.5 seconds to hear the reply, the time for the signal to reach the moon and come back. Imagine a conversation where every sentence takes 2.5 seconds to reach you, and yet the moon is right next door. Next stop, the sun. Distance 150 million kilometers. Travel time 8 minutes, which means the sun you see in the sky right now isn't the sun of this moment. It's the sun from 8 minutes ago. Its light took all the time to cross space and reach you. If the sun went out at the exact instant you're watching this, nothing would change in the sky. It would keep shining. The Earth would keep receiving its warmth for 8 full minutes before everyone realized it at the same time everywhere on the planet. Heading to Neptune, the farthest planet from the sun. Distance 4.5 billion kilometers. Light gets there in 4 hours. In 1977, NASA launched the Voyager 2 probe on a mission to explore the giant planets of the solar system: Jupiter, Saturn, Uranus, and Neptune. It reached Neptune in 1989 after 12 years of travel. 12 years versus 4 hours for light. To this day, it's the only probe ever to fly by Neptune, and the images it captured took 4 hours to come back to us, racing at the maximum speed of the universe. And Neptune isn't even the end of the solar system. Beyond it stretches the Oort cloud, a vast halo of icy comets surrounding the solar system far past the last planet. Now that we've left the solar system, we head for the closest star to us after the sun, Proxima Centauri. And here, we're going to need a new unit because the kilometer just isn't enough anymore. If I gave you the distance in kilometers, it would be 40 trillion, a number no one can picture. That's why we use the light year, simply the distance light travels in 1 full year, about 10 trillion kilometers. Proxima Centauri is 4 light years and 2 months away. 4 years of travel at the maximum speed of the universe just to reach the nearest star. Around it orbits Proxima b, a rocky planet in the zone where water could exist in liquid form, one of the conditions needed for life as we know it, even if that alone isn't enough to guarantee it. And keep in mind that our galaxy holds about 200 billion stars. Proxima Centauri is the closest of them all, and it still takes 4 years to get there, to reach the closest galaxy to our own. the one many people know. Andromeda, the travel time crosses a monumental threshold. It would take 2.5 million years of travel at the speed of light. And here's a fact that's truly dizzying. Andromeda is the farthest object a human being can see with the naked eye, without a telescope, on a truly dark night. It's just a small, fuzzy smudge in the sky. You can't make out a single individual star, only the overall glow of its hundreds of billions of suns blended together. And that glow we catch tonight left Andromeda 2.5 million years ago, at a time when our very first ancestors were only just beginning to walk upright on Earth. One more thing, Andromeda is racing toward us. In about 4 billion years, it will collide with the Milky Way. That leaves the final frontier, the edge of the observable universe. Distance, 46 billion light years, a number beyond all human intuition. But there's something even more unsettling. The universe isn't fixed. It's stretching constantly in every direction at once, a bit like the surface of a balloon being inflated. And some regions very far away are moving away from us faster than light can travel. This doesn't break the laws of physics. It's not an object going faster than light. It's space itself expanding. The result, their light will never reach us. No matter how long we wait, even for eternity, there are parts of the universe humanity will never see and never reach. So there you have it, light, this speed that nothing in the universe can exceed. The one that crosses the Earth in 1/10 of a second turns out to be almost laughable against the vastness around us. 4 years for the nearest star, 100,000 years to cross our single galaxy, and entire regions we'll never see, no matter how long we wait. We're sitting on a tiny planet around an ordinary star in a lost corner of one galaxy among trillions. It can make your head spin, or it can make you want to look up at the sky differently tonight, knowing what it truly represents. If you enjoyed this journey, subscribe and tell me in the comments which distance blew your mind the most.